find the volume. Sorry. So we are going to find out the volume of the common portion between your ellipsoid and the cylinder. So if we draw it, then what we need to find it. So the ellipsoid is look like this. Then the cylinder whose base is on yz plane, so we consider this one is your y, this one y, this one is in z, so plane a part of it. We are going to find out this common portion. So if we consider that y square plus z square is 1, so therefore we have x square has its range, which is your less than equals to.
But the base of the cylinder should lie in YZ plane.
Yes, we are considering on that YZ plane. Oh, base of the cylinder is on YZ plane, so that should be your x, right? That should be your x. And that base is on there. That should not be x. This one should be your y. This one is x. This one is z. That's right. Then it is 10 minus 2, which is 8. So x has its range from your minus 2 root 2 to root 2. Now we are considering here the cylindrical coordinate by considering your x as it is. So therefore we have the range for the common portion is your E as its x r theta, where x is considered to be from your 0 to less than equals to x less than equals to under root of that's 2r. R is ranging from your 0 to 1, and theta is range from your 2 pi. So we are considering that x is fixed, and then y equals to r sine theta and z equals to r cos theta. So by that we are changing this all. By that change we are getting this range, and therefore the volume can be computed from 0 to 2 pi, 0 to 1, 0 to under root of 10 minus 2r, Then you have r dx dr d theta. And then after all, if you integrate this one, you will get the answer nearly to be 2.9985. So consider the problem.
So can you show the answer again?
Answer is nearly
Why haven't we
2.9985.
taken the lower part of the cylinder?
We have not taken that lower part. We can take this is multiplied by 2. If you consider multiplied by 2 on your x-axis, we will get that the whole portion, that is 0 to this portion. So here we need to be multiplied by 2.
Sir, how is R 0 to 1?
Which one? R for? R is the radius. If you consider that y equals to your r sine theta and z equals to r cos theta, then we are getting that the range for your r is 0 to 1.
Sir, once explain the limits for x. 0 to under root 10 minus 2r.
10 minus 2r is your 2 into, is it r or r square, I think. 2 into, that should be r
R
square.
square, sir.
It should be r square. Y equals to r sine theta and z equals to r sine theta. That is 2 if you take common, 2r square. We'll get it 1. So x square is less than equals to 10 minus 2r. So that is your minus under root of 10 minus 2r 2 plus under root of 10 minus 2r. We're taking that from 0 to under root of 10 minus 2r. Then we can do that integration. And that the whole circular portion will give you that.
Sir, but when considered from 0, isn't that the limits for theta
Yes, sir.
changes, sir? Because it is taken from
Yes.
0 to 2 pi, no, sir?
Theta is taken from 0 to 2 pi. That is the whole circular
So
region.
instead of that, we can change theta from 0 to pi by 2 and multiply it 8 times.
Then also, then you have to make it change there. 0 to pi by 2 and then multiplied by 8 times.
Sir, how we got 10 minus 2, sir?
Yeah, 2r.
X square is less than 10 minus 2 in the first step.
We are getting this one in terms of your Cartesian coordinate, but this is your fixed, that's the point of intersection from these 2 points we are getting. But if you make it change, that is y equals to into the cylindrical coordinate, it's better to remove this portion because we're not going to do this. We are considering actually x is fixed. It is y equals to r sin theta and z equals to r cos theta. X is x. Therefrom, we are getting the range of your x r theta in that form.
तो ये वॉल्यूम इक्वल्स टू 2 क्यों आया है, तुमसे मल्टीप्लाई क्यों किया?
We're taking this portion actually divided into the equal part. Okay, so from 0 to this portion, it is symmetric about your yz plane. Okay. Find the volume. Someone should mute your mic by a sphere. Banavatu Bala Raju You mute yourself. Balaraj, you mute yourself.
The screen is not shared.
Yeah, I'm saying. Square equals to the cylinder. With base x square plus equals to 1. So here also we consider the same that of your cylindrical coordinate. So if you consider that x equals to r cos theta, y equals to r sin theta, and then after z equals to 1, then your range will come up something like that. If you consider is your z, this is y, this is your x, then you have sphere. The sphere becomes larger than that of it should be. Its radius is 1, so that is smaller than that of your 4, that is 2, and then there is no bound on z axis, so we can consider that is over there, at the point of intersection. This side should be there, something like that, the portion is it. So that point of intersection is your 0 to 0, this one is 2 0 0, this one comes to 0 0 2. Now the range, then it will become E equals to your z. So we are considering the upper portion, that is 0 of to z, that is your 4 minus r square, that is under root of 4 minus r square, and then again your r is ranging from 0 to 1, that is the common portion, and theta is equal to 0 to 2 pi. And then after the integration you can do, therefore volume v equals to integration 0 to 2 pi 0 to 1 0 to 4 minus r square r dz dr d theta. After evaluation you will get 2 pi 8 by 3 that unit, cubic unit. We can solve, this is the same as of your problem number 1. Now problem 3, find the volume. bounded by
So can you show the last page again?
yes,
So can you show the last page again?
last page. Okay.
The range of Z. Sir, why didn't we consider a lower portion?
Yes, sir. Range
Yes,
should be
sir.
minus also.
Same question.
Yes, sir.
Plus
Minor
root 4.
should.
No.
Yes, sir.
This is the
Twice it, sir.
basement. We are not considering here in this case of your the lower portion. Actually, base is your x square plus y square.
So the hemispherical surface we are taking. Hemispherical.
Hemispherical we have considered, but it is not being mentioned. So we need to be considered that the whole one
Take it twice, sir. That's it.
and take it twice.
Yes, sir. Take it twice. It will be perfect.
It's right. So I think this should be multiplied with your 2.
Sir, I also want to ask a question. How to visualize ellipsoid? Means
It's ellipsoid.
yes,
Ellipsoid
sir.
visualization means you have to rotate an ellipse, then you will get that the solid figure that comes to your ellipsoid. It's better to do
Torbuj.
yeah. Not that all type of tormoj, means watermelon. One species is coming up, that is in Bengali says it to be your khormuj, which is look like that, but tormoj is sometimes look like a sphere.
Rugby ball.
Rugby ball
So watermelon type.
or egg you can consider. Egg has its also one portion is your larger than that of the another one. That is asymmetrical ellipse you can consider, but that is rugby ball is quite symmetrical in the form of your ellipse. Now if you rotate this one, so you will get one 3-dimensional figure, and then we
If
can
we
consider
rotate this one in the y-axis of
uh, no,
axis or axis.
if you rotate in your y-axis, it will not be give you that type of your ellipsoid. Means if you are
It
rotating,
will look circular moreover.
it will take some, what will happen, that upper portion will look like a circle, that this type of thing will come, and means that will be look like something, I think what it looks like. If you rotate about your y-axis, then it will not be look of your ellipsoid, but if you taking the rotation about your x-axis, then you are getting the solid that is called your ellipsoid. Because for y-axis, it's rotating about y-axis means it takes the major axis will be larger, and that portion will come to your upper portion is your circle, and that lower portion means on the xy plane it comes in the form of your ellipse. So it has not been shown how it's look like, means a combination of your ellipse and circle. Okay.
Sir, in this case, how to write the limits for Z, sir? Once explain it, sir.
So you consider x equals to r cos theta, y equals to r sin theta. So that comes to x square is sorry, r square, and these two portion gives you r square. So z square is equals to your 4 minus r square. So z has its range from your plus minus under root of 4 minus r square. We are taking the positive portion, that's why we have taken here the 2. Now for the range of the cylindrical coordinate, that basement is of your circle, so r square is equal to your 1. So we are considering that portion, that is the common portion between your means half hemisphere for your half sphere of your this one and this one, that is the common portion will be this. So we are considering this, the range for your r 0 to 1, and we are rotating about your the whole circle, that is 0 to 2 pi. Okay, so the range for theta is
When we are
coming.
taking only the positive side, isn't that theta, sir? Theta limits I can't understand. Once explain, sir. How
Theta,
it is?
you for a circle, if you have to consider the whole circle, then what will be the range of theta? How much the theta should have to be rotate on your xy plane? That should be 0 to pi. The angle creates at the center of the theta is your 2 pi. So the theta rotates of your 0 to 2 pi. That's why the range for your theta is coming up to be your 2 pi.
Okay,
Is
sir.
it?
Okay, sir.
Volume.
Sir, in this question, we use cylindrical coordinate. Sir, may we use spherical coordinate here?
Herein, if you use the spherical coordinate, is it required? Because spherical coordinate actually to some typical. If you
We
use that
don't have
spherical,
spherical symmetry here. How can we use?
yes. As well, when we can do that the problem solved by your cylindrical coordinate, we will not be go to your spherical coordinate, because spherical coordinate has your more variables. It means one more, that is your phi, we need to be considered. We just solved the one problem in your spherical coordinate. Just after that, the next problem, like a sphere.
One doubt is there. Sir,
Okay.
why spherical coordinate the range of phi is 0 to half rotation is considered, means 0 to pi. Why not 0 to 2 pi, sir? That is the question.
Okay, I will come to that. And cone is z equals to under root of y square. Okay. So the thing is, as you know, that in case of your z, x, and y, if you consider any point in your space, which may be considered to be lying on your sphere, then the spherical coordinate is considered in such a way that you first take the projection of this point in the xy plane. Okay, that takes something like that. So for that, you have
सर
your, yes.
सर
हाँ,
ये क्वेश्चन मतलब कल सर करवाए हैं सर ये क्वेश्चन
सर करवा दिया.
AKD
Okay, okay. So it's good. Okay, so I no need to be solve this one. Okay, so in case, so I think that time sir has been said. Okay, so that is your supposed to be your x coordinate. This is your y, and this is your z. So for that we have makes an angle with your theta. There is forms here theta. So for this one, as you know, representing your r cos theta, this point is your r cos theta and r sin theta, cos theta and r sin theta. Now we have taken the projection of this point. So with respect to that point, we are getting this. Now if you consider this with respect to this point, then you have that creates another angle with your z axis. So that angle is denoted by your phi, and for that, for each of these has its again the value, that is your r cos theta sin phi, r sin theta sin phi, and z for your r sin r cos phi. Okay, now for this angle phi has its range from your xy plane, this side, means if you come to this one and up to this one, if you extend this portion, so then you can see that is your from pi by 2 to minus pi by 2, it's rotate between that. That will cover all these your upper half. That's why we are considering that the range for your phi is from
Yes,
this
sir.
portion
That
or
is
here?
the only. Sir, why not in lower half? In lower half, also the points can be there in the
Huh.
negative z axis. Why are we
Huh.
not considering?
We are not considering because of that the upper half, that depends upon the problem. I think if you consider the whole sphere, we must have to consider the lower part. But if the problem is on your upper half, then the point should not be in there. And if it is in the symmetric form, we can take the multiplied by the 2, of course.
So how theta comes pi by 4 here? That's not clear in the previous class. But there's no time to ask. Please explain the point.
Yes, sir. Yes, sir. That thing also.
The theta. So theta, you just consider that is your for the cone that you have z equals to under root of, I think, x square plus y square. So that comes to z is what? R cos phi.
Sir, can you explain this portion again?
Which portion?
R cos theta sin phi one.
Just wait, I just explain this fact first then. So z equals to your r cos phi. According to this, z equals to r cos phi, and that is equals to, if you're taking that x square plus y square, r sin phi.
Yes, sir.
So of course that you have sine by cos, it comes to tan.
545.
Yes. So this implies is pi by 4. That comes to your pi by 4. Okay, and theta in this case is not of your the pi by 4. Theta is in this case is rotating about your the whole, because we are considering here the sphere which is passing through your origin. So that is in the sphere, if you consider, and the cone is also passes through origin. It's of something like this. Then it's rotate that the cross section of between these two. So we are considering that the whole circle. So for that whole circle, we are getting that its rotate for theta is your 0 to 2 pi, the whole one. And r, it comes to from this ranging from r equals to, that is the z range. So r is ranging from 0 to phi, cos phi.
R cos phi.
R cos phi. Okay. So if you consider any point on your any sphere, then you can get these things, that is x for something, y for something, z for something. Now for any point you take the projection on your xy plane, and you know that r theta form we can represent any point in on your xy plane by your r cos theta or sin theta. Then after, if you consider that phi, so if you have to know that how this comes on, then you have to consider that angular calculation that creates some right angle triangle. Then therefrom you are getting some sin theta and cos theta, that you need to put some names, and then you have to go through.
Yes,
You'll get
yes,
this
sir.
one.
Sir, explain graphically, sir.
Yes,
Explain graphically how it comes, please, sir.
graphically. Then we have to give the names and draw this one. You may go through it. It is present in there. Because you have to put their names, that is some points, a P, and that is your A, then it comes to yours is your O, then this one is your right angle triangle, that creates an angle your phi, this is an angle your theta. So you have to draw some perpendicular on there, with respect to which this coordinate is your xy. So this comes to your under root of x square plus y square. This one is your y, this one is your x. Then for x equals to, you have that r cos theta, y equals to r sin theta. Then accordingly for these two, I think we need to compute some value for this. This is your z actually. This is your z. So now we need to be represent that x in terms of your phi and y in terms of your phi with respect to this one. How that represents, that you draw it larger. Then I think you just go through, you may get in, because those points we have just used directly. That is for x equals to this coordinate, y equals to this coordinate, and z equals to. But that is not too much harder. If you once you go through, you will get that proper idea. Everywhere it is present. That is a spherical coordinate. Need to do that. Okay.
Sir,
Yes.
sir, we know, sir, z equal to x cross y. So here, sir, z equal to minus x cross y. Sir, why?
Z equals to x
The
cross
direction of
y.
z axis, x cross y. So why, sir, here minus x cross y? The direction
Sir,
of
you
z
have
axis.
taken the coordinates
It may
wrong.
be we are taking that x cross y, that you are asking that why the direction is in the different. That may be for your positivity. Okay, that the direction is taken to be in terms of your right hand rule. For that, we are just considering that one. Just to maintain that positivity, we have to consider that of the minus one. Minus is comes just because of the direction, nothing else.
Okay, sir.
Okay,
Sir,
so
please,
once you have solved, yes.
sir, please explain the dv part for spherical coordinate. There is some doubt.
Which part?
Sir, how dv is coming? Small volume, that rho square sine
So
phi.
dv
That.
rho square sine phi. How is it coming? He is asking that.
Oh, that means the Jacobian you're asking?
Yes, sir.
Okay.
No, sir, not the Jacobian. Sir, the normal thing, the spherical coordinate,
So for
in that
spherical coordinate.
it comes now rho square sine phi d rho.
That means you are representing that x, y, z. That is x equals to r cos theta sine phi, y equals to r sine theta sine phi, and z equals to r sine phi, r cos phi. Now for that one, your representation means transformation from xy coordinate to, if you are representing this one, that is in the xy coordinate, this is supposed to be x, this is your y, this is your z. If you consider that the small portion, that the small block, and you are representing that one in terms of your some r theta or rho, whatever you are saying, rho theta and phi, in terms of that coordinate, it comes to some maybe slanting side. It's symmetrical, it's not asymmetric. So you have it. It's a small block you are transforming by some transformation rule, and for that your dx dy dz it transformed to dr d theta d phi. And it has been seen, or it has been seen that whenever you are taking the transformation, these portions volume and this portions volume, or you can say in case of your 2D also we use that Jacobian. So that Jacobian is required, the transformation rule is required. Otherwise you are not getting the same volume. In this case, in case of your area, we are not getting the same area also. Okay, so that with that we need to multiply one factor, that is called the Jacobian, and that Jacobian value is coming up for your whatever you are saying, that is in terms of your rho, that is r square sine phi. Okay, so the computation of this Jacobian, you know that if you have x equals to r cos theta means that transformation, then you need to be find out that is del of Jacobian for your r theta phi, and that gives you this value. Okay, so I think you have been done so many things. Very good. Volume bounded by, so then you can solve this one also, bounded by the cone z equals to under root of and the sphere. Now for this case, could you solve without using your okay, I'm writing this equation of sphere, spherical coordinate. Spherical coordinate you have just now solved, so you can solve it, of course, but without using the spherical coordinate, you try to solve this one. So solve without using spherical. Okay. Problem.
Sir,
Yes.
sir, in finding that Jacobian, that is r square sine phi, we have to do 3 times the partial derivative with respect to r, eta, and phi, sir.
Of
Okay,
course.
okay.
Please show problem 4.
Problem 4. Okay.
Okay.
Okay. Find the volume. This find the volume of the region bounded by outside the cylinder whose base is, I'm not writing, there's just only the base equation I'm writing, that is your x square plus square equals to 1 and sphere inside the sphere. So the sphere is your is this. So this one is again is something like this. The figure is that is of your z, y. You can consider that is your x. So consider the sphere. It's not to take too much larger one. Expressed.
So this question is similar to problem 2, I guess.
Problem
Yes,
number
sir. Same
2.
question.
That is the
Exactly
cylinder.
same.
But that time you have considered the common portion of inside the cylinder and the sphere. That time you have the bound only on the z axis. There is no bound in your the common portion. But this time we are considering the outside of the cylinder whose base is the same and inside the sphere. So that
Okay.
time we
Then we
that is
can
the
subtract that one from the whole thing, no, sir.
yes. That
The
means
limits
from
of
the
x are changed.
limits are changed in actually the x coordinate. I mean x and y coordinate, and the boundary portion we need to be considered. Okay. So we have the sphere whose base is your x square plus y square equals to 1. So we can consider here something like that. My drawing is good. That is one. Let's also be intersect. That is one. So we are considering here the basement. So this, so that is of radius your 1, that is of radius 1, and that is the outer portion is of radius your 2. So this portion we need to compute. This portion we need to compute. It is the outer part and the inner part of the sphere. So you can use directly for the range for your Z. The hints I'm giving you, that is the volume of that portion. So integration, integration, and integration. Then for your Z has its range minus under root of 4 minus x square minus y square. That is also because that portion is common to both the cases, under root of 4 minus x square minus y square. Then you have that is your dz. Then for y, minus 4 minus x square under root of 4 minus x square, and x as its range from minus 2 to 2 dz dy dx. That is the inner part of the sphere. Then minus the cylindrical, that is also z equals to the intersection of these two, so the same range, that is 4 minus x square minus y square. That is dz. Y will be your under root of 1 minus x square minus x square, and that for x is your minus 1 to 1 dy dx. That's the volume we can compute. Then you can find out the value. Yes.
Is that we first sum and subtract it from the total volume of the sphere.
We subtract that cylindrical portion. Okay. So the last problem, that is most interesting. So double integration over d.
Sir, yx limit is by from minus 2 to 2.
Which one? Last one? Minus 2 to 2, that is the for your range of x. If you put that x equals to 0, y equals to 0, z equals to 0, x square comes to your 4. So x ranging from your x square is 4, so x equals to plus minus 2. That is from your minus 2 to 2. We are considering that the whole inner part.
For finding the
Sir, I
limits for
want to
y, is it
One by
must
one.
to the z is equal to 0, sir, or is
Finding.
it mentioned in question for finding the range limit for y?
Y. Y for
Here
your
we
sphere.
substitute 0, na, sir, in place of z, and we have calculated that under root 4 minus x square.
We are putting that z equals to 0. We are getting that y equals to y square is 4 minus x squared. So y equals to plus minus under root of 4 minus x squared. So we have taken that for your sphere. Okay, that is the portion of your cylinder. But you have that the common portion between them, that is the range for your z. Okay, that's why the z range is same. Only the changes are in the basement on the xy plane.
Okay, sir. Okay.
But will it not consider the inner volume also? Because why we are ranging from root over of 4 minus x squared to minus root over of 4 minus x squared?
I could not understand. Root over of 4 minus x squared to root over of
So
4
the limit which we are putting in the previous problem, sir, will it not consider the inner portion of the cylinder also?
We are not considering the inner portion of the cylinder.
So then why the limits are like this? Because it will range for the.
Sorry. We are considering here the inner portion of the cylinder that we are subtracting from this one. Then only you are getting the outer side. Na? This is your inner portion. That's right. We have to consider. Is it?
Sir, can't we write only one equation for the whole thing? Like not without subtracting.
Without subtracting, then you have to use the substitution. You have to use the substitution. This is your spherical. So of course you have to consider that spherical coordinate. That you can also be do. And that will actually much more easier. So that's the thing why we are using the spherical coordinate. When the problems are much more complicated, we need to be using. Here ft is the greatest integer function. T less than equals to t. So
Sir, we have done,
yes.
we have done this problem, sir.
Okay, then
6
it's
hours.
Is doing
Yes, sir.
understand it properly.
Sir, but
Okay.
explain it.
Actually, I am also saying that you should try this one. I will explain you in the next class. Okay. So what we are doing in this case, we are actually using the Jacobian. Okay. So we are using here one substitution, that is x plus y equals to u and y equals to v. For this, you need to use that the Jacobian. And if you use the Jacobian, what is happening by this in your xy plane, you have that 0 to 0 2. So that is the region on which you are taking the integration. We are shifting this by this transformation to this, that is x plus y is equal to your u. So that means we are considering here on the line, like this. So that is your 2 minus v equals to 2 minus u. Okay.
Sir, why you are considering y equal to v?
Sir, the slope is negative for the first value. Sir.
That is your u. V equals to u.
Region
This
is
is
not
your
like
v equals to
normal. So the region is triangular, like with the negative slope.
I'm coming. Wait. V equals to 0. No, you say what you are saying. Which one is negative slope? We are considering that x plus y equals to u. So if you now put the different values, you are getting here the different range for your u and v. Is it? So if you what are the points? What are the points you are getting from there? Your points are now, if you put x equals to 0 0, then one value for u is your 0. Okay, so u has its value 0. If you put x equals to 0 and y equals to 2, so one value, or x equals to 2 and y equals to 0, then u has its another value is 2, and another one is x2 y2, so that is comes to 4. So these are the 4 possible terminal points for your u. V has its range from your 0 to 2, because y is 0 to 2. Okay, now you can create the terminal points, that is 0 0 is 1, then you have 2 0, that is u is 2, then you have 2 2 2, you have 2 2, and then 2 4, 4 2, sorry, not 2 4.
4 2.
Actually, I'm running out of the time. These are the 4 points. Now you just add these 2 points, these 2 portion, then you can integrate by considering that v equals to 0 to v equals to u, and u has its range from your this point, I think, to be u equals to 0 to u equals to 2. This is the line, that is v equals to 0. So that for u2, and that is also v2. So that is the point where you have that is 2 2 point. So therefore one limit is coming from v equals to 0 to, if you consider the strip, something like that. So v has its range from 0 to u, and u has its range from 0 to 2. Then again v has its range from your u plus 2 to 2, if you consider this one, and v has its range from this is u has its range from 2 to this point is comes to be your 4. Actually this point is your 4. Then after you have to use that the greatest integer function, and then you can be solved. I think you have done this one.
Sir, once explained that y is equal to v, sir, part why it is considered.
That is actually your transformation. That transformation you have to choose depending upon the problem, what transformation rule you have to follow, so that
Problem
we
moving
can.
on x plus y is we are considering as u. Is it enough, sir? Again, considering y is equal to v.
That is, no. You are considering the two variables, so you have to use that rule, because only considering x plus y equals to v, so that will not be sufficient for your transformation. What about that v is? How you are transforming? Sorry, what about that y is? So you have to associate two variables with your x and y.
Sir,
Otherwise, how
so
do you
here,
create the coordinates?
Yes, y is equal to v, x equal to
Sir,
u
I
minus
want to
v.
ask a question.
X equals to u minus. If you take that subtraction, you will
sir,
get
once show how to calculate the value of Jacobian, sir, for any problem. So we haven't been shown how to do it.
Okay, I will give you in the next class. Okay, actually, I don't have the time.
Sir,
The
I
how do you
want to
calculate
ask
the
in
Jacobian?
previous
And
a question.
yes.
Ask a question in previous question. Problem. Problem 5. I want to ask a question.
You ask.
Sir, can we take limit of y from under root 1 minus x square to under root 4 minus x square directly, and limit of x 1 to 2?